Okay, this is video 1 for chapter 9, which is the chapter about bonding. We've already kind of covered a little bit of bonding in some of the earlier chapters. I think in chapters 2 and 3 even we kind of introduced bonding a little bit. But this chapter kind of really gets into it, gets into the heart of it. So the reason why this chapter is here is that it's kind of important to cover quantum mechanics, which we already covered, which really, when you think about it, only really talks about, or chapters 7 and 8 that we covered already, really only talk about properties of the atom itself, basically an individual atom of a certain element, whether it be an ion or the neutral atom itself. That was what chapters 7 and 8 talked about. We talked about orbitals and essentially the question of where is the electron, where are the electrons for an atom. And that's when we talked about valence electrons and the inner shell electrons and all that jazz. So in reality, in nature, almost all substances have some bonding. It's really the exceptional cases of substances that exist in their elemental form that are monoatomic, meaning only a single atom. Takes even something like oxygen. Oxygen that we breathe is a diatomic molecule. It's two oxygen atoms that are bonded together. So almost all substances have some form of bonding. And but now we're getting into kind of the meat here of the course. It was important to introduce quantum mechanics generally, and also kind of the elements and some of the atomic properties, because those atomic properties actually affect the types of bonding that the various elements engage in. Okay, so again, I like to characterize. Even in the previous section, we talked about quantum mechanics. You can sum it up as a question of where is the electron, or where are the electrons. And in bonding, that's still the exact same question, because bonding essentially takes place because of electrons, or say electrons are heavily involved in all forms, all the three major forms of bonding, as you'll see. So this video is going to kind of introduce bonding, and then there are basically three. The chapter 9 talks about three distinct types of bonding, which I'll introduce here, and then I'll end the video, and we'll talk about each of those types in subsequent videos. Okay. So, but a couple basic things about bonding. So there's an interesting question that's covered in the text, which is, why do bonds form at all? And again, I mentioned that almost all substances involve bonding, but why is that? Why do atoms bond together? And the answer is simply that when atoms bond together, they form a lower energy state. This goes way back to the very first video when I said chemistry is all about electrons and energy. Basically atoms bond together because when they bond together, the electromagnetic forces are more stable when they are co-located. When a positively charged particle is co-located with a negatively charged particle. And another way of thinking about this energy thing, because the book talks just assumes that you just kind of get the energy concept. I want to make just kind of in case you have any doubts. Let me just throw an example. Is that let's imagine we have I'm going to use two hands, but let me get two items. Let's have I don't know. Maybe this is overkill. Let's just take a pencil and a pen. Let's say that I don't know, better. How about this? No, that's not good. All right, already spent way too much time on this. Two objects. The blue is positively charged, and the brown is negatively charged. Okay, and as we know, they like to attract. Okay, and so let's imagine that they get this close, and so they're attracting each other. Think of them as two magnets, but instead of a magnetic force here, I'm talking about electrical force, but it works the same sort of way. So it basically, once they're this close together, it takes energy. I have to pull them to separate them. They want to be close together, so I have to actually expend energy to pull them apart. Another way of saying that is that when they come together, they form a lower energy state. They're down at the bottom of the energy well, and it takes additional energy to pull them apart. So this is why atoms tend to bond together, is that in doing so, they minimize the energy related to the electrical forces. We'll say that. Okay, so that's why they bond at all. Now, I mentioned earlier that the types of bonding that occur are affected by the atomic properties, and this chapter points out that you can think when you look at the periodic table you can split into really three types of elements. There's elements that are known as metals, which are metals like we think of metals, and in figure 9.1 it shows that most of the elements in the periodic table are metals. Then there's non-metals, which are shown in the right side of the figure. These are, again, they're like carbon, nitrogen, oxygen, all the halogens, all of the noble gases. Basically, kind of like the lighter and also more electronegative elements are considered nonmetals. And then there's a group of elements that are known as metalloids. It's almost like they're kind of they're kind of halfway between nonmetals and metals. That's kind of interesting. However, I mean it's interesting depiction. It turns out the rest of this course doesn't really focus on metalloids much. They're a subject on their own, really. But it's just kind of interesting how they align in the periodic table. Maybe it's worth taking a look at that. So, in general, when the rest of we talk here, we're going to be talking or classifying elements as either metals or nonmetals for the most part. But just note well that there is kind of this middle ground, which the book calls metalloids. Okay. Now, in the same way that there's middle ground there between metals and nonmetals, there's also middle ground in some of these bonding types. So I only introduced the bonding types. So the three main bonding types that we'll cover in this chapter, and for that matter for the rest of the course, are known as ionic bonding, which again we've discussed quite a bit already, covalent bonding, and then metallic bonding. I'm going to introduce them really briefly here, and then I'll get into each of them more as in the separate videos. So in ionic bonding, what happens is that typically a metal will give up its electrons, will essentially transfer its electrons to a nonmetal. And essentially what happens there is that the metal then becomes positively charged since it lost electrons, and the nonmetal becomes negatively charged, and therefore they will attract. And when they essentially have a positive and negative substance there, a particle, and they tend to attract each other, bond together in a form known as ionic bonding. And all that means is that we're talking about bonding ions together, a cation to an anion. Okay. Second form of bonding is called covalent. In a covalent bond, what happens is instead of the electrons being transferred from the metal to the nonmetal, they're essentially shared. They're shared between two atoms. And sharing is an interesting concept, especially since we just talked about chapter 7 and 8. And what I mean by sharing is that the electron is expected to be, again, it's always a probabilistic thing, but it's expected to be somewhere between the two atoms. And so from each atom's perspective, they think that the electron is kind of associated with them, meaning the electron tends to have this electrical influence with each of the atoms because it's co-located, generally speaking, somewhere in between the two atoms. Anyway, and then certainly I'll talk more about that in another video. And the last form of bonding is known as metallic. And by the way, I'll probably cover metallic and ionic together in the same video. But a metallic bonding is kind of a special case having to do with metals, real metals. I'm not talking about ions, but a metal like like copper and iron, etc. And those metals, in that form, where the electron is a bit unusual, and we'll talk about that more when I get into it. Okay, I think that's all I want to do by way of intro. Yep, that's it. Oh, the only thing I'll cover just last is, and not saying is in this chapter, we first introduced the concept of Lewis dot notation. And just look at that. It's very simple in chapter 9. It gets a bit more complicated, or something similar to this becomes a bit more complicated when we get into chapter 10. But in chapter 9, just take a look at that in the text. It explains it really well. And all it is a way of essentially depicting the valence electrons associated with any atom. Okay, I'm going to end this one.